now your background, like chemical engineering, like when did this start? Did you was it like a dream you had, or when did this start? When did this journey start?
Sure. So it wasn't necessarily a dream that I had. All of my secondary school, I thought I was going to be a doctor. I thought I was going to do medicine. I thought I was going to be a doctor until I actually visited the hospitals. And when I went to the ICU, I realized, you know what? I don't have the strong heart for it, because I almost cried. So I can't be a doctor if I'm going to cry when I see people in pain. So then from there, I was a little bit...
You were telling us the difference between chemistry and chemical engineering.
Yeah.
Okay.
But I can start off by saying chemistry looks at chemical compounds more at the molecular level and how chemicals interact with each other. So that's essentially what analytical chemists do, is to look into the molecular level of chemicals. But then with chemical engineering, we touch on that a little bit, but essentially we look at how those chemical compounds interact through a process stream. So we need to make sure that the chemical at each section of the process, we need to understand how it behaves, how it flows, how it heats up, how it cools down. And we need to make sure that the equipment, that whatever chemical is strong enough to withhold whatever is happening, whatever chemical reaction is happening in that. So it uses chemistry, but then it's more than chemistry. That makes sense. Yeah.
Okay.
So chemistry is like the people literally behind the scenes, making sure that looking into what the chemical reaction looks like. Okay, A plus B gives us C, but maybe A plus C also gives us something else. That's chemistry. But then we get the more bigger picture with regards to how can I get from A to Z with efficiently, safely, without causing environmental concerns and all of that. Yeah. So that, I think, I hope that will help someone understand that it's not just chemistry.
I remember you mentioning you really didn't do even much of chemistry in your undergraduate.
It was just 1 year. 1 year or 4 years was chemistry. Everything else was just maths. Yeah. But so I don't know if you can actually share the flow sheet so that it might make a bit more sense. I hope I don't scare anyone.
Okay. Let's see. Are you able to see it?
It's still loading. It's still loading on my side.
Let me know when you see it.
Okay, I can see everything. Yes.
Yeah,
that looks great.
Definitely scared. We're scared.
No, trust me, this is not scary. This is fun. This is so much fun.
So what are we looking at?
I honestly enjoyed creating this flow sheet. So basically, the vaccines that they were rolling out back then, COVID, basically how you start off is what we need is something called an mRNA strain. That's just a biological term for what the type of vaccine that's used to treat COVID. It's just something called mRNA vaccine. So how you actually produce that is... Oh, I'm gonna scare people here. Basically, it's a biological process. It's a biotechnological process that the pharmaceutical companies have adapted. So essentially, we're all made up of DNA. We know that, right? DNA, it's basically what makes you and me. Fine. So what happens is with the vaccine, they isolated a part of a DNA strand that helps to treat COVID. So instead of, and that vaccine, that little small fragment that you use for the vaccine, they found a way to engineer it, actually, to recreate it without having to look for natural resources, right? So what they did manage to do is they isolated that little part, and now basically what this whole process is upscaling it. So how do you actually get DNA? It all boils down to biological processes. So something called fermentation. You know, bacteria, they are naturally occurring. You'll find a bacteria anyway, anyhow, right? Big, small, whatever. So what they have done is that through something called protein engineering, they've made sure they found common bacteria that grows rapidly. It's called E. coli. And they've added that little small segment into it such that when it replicates, you get more of that little segment that we want. So that's at the beginning. So at the beginning where we have meat, I'm not going to explain the entire flow because it's very long, but then just the beginning where we have media flowing in. So that's basically the food for the bacteria that contains the vaccine that we want to then extract. So we first need to grow it. You first need to grow your bacteria. So you can't just grow it out of... So the thing is, working with living organisms is where the biotech or the bio side of chemical engineering becomes interesting, because you need to treat your organisms nicely. Otherwise, it won't grow. And if it doesn't grow, then you don't have a process. So that's why you start off with smaller volumes. At the beginning there where it says fermentation, you start off with smaller volumes until you have a big enough volume where you can now extract this your vaccine that you want, the mRNA strand. So essentially, every step of the way, all those little equipment pieces, we would have designed them. Everything from the mixers to we would have designed them. But not obviously by ourselves. We also need your mechanical, your electrical. So I'm always going to say this because I don't want to seem like, oh, we know no, chemical engineers do not know everything. We don't. We work together. That's a very important thing that I learned throughout my chemical engineering journey, is that we work together. We need to come together to solve problems. So as opposed to chemistry would have looked into maybe, okay, what are the chemical compounds that are going in? But now, as a chemical engineer, I'm going to look at every single piece of equipment and make sure it's heating properly, it's making sure that the mass is flowing nicely, all of those things, the fluid behavior, that it's not too thick for the stirrers, all of that we consider chemical engineering. So basically, it starts off with just media and a little bit of bacteria, and it grows. And then if you can just scroll to even the end, because after you've produced what you want, you now have to separate everything out. So that's basically the rest of the process. If you could just scroll down to literally the end, everything after that is just... Oh, you scrolled fast. Okay, yes. Everything after that is just...
Sorry.
No, it's fine.
So, actually, I wanted to ask you, because you mentioned, can I ask something? You mentioned that this was something that used this to develop the COVID vaccine. Was that it?
Yes.
So did you work on this during COVID?
No, I actually worked on this towards the end of last year, is where they're trying to see how to make savings. Yeah.
Okay.
So no, unfortunately, during COVID.
So does it also
during COVID. No, go ahead. Sorry.
So then, does it mean that you work with doctors as well? Because if you'd be working to maybe see how to make the vaccine more efficient, then you'd need input from doctors as well.
In this particular project, not necessarily. It was more of the research and development team that I worked with, so R&D. So I didn't necessarily interact face-to-face with doctors, but I'm pretty sure that their input is also needed in this. Yes, you're absolutely right. Yeah, you are right. But just, not in this particular project. Yeah.
Okay. I want you to tell us what we are looking at, because you're telling us this is what chemical engineering is all about. Is this what a chemical engineer should expect on a day-to-day?
Yes, actually, yes. because remember, you're going from raw material to final product. So as long as you're starting from A all the way to Z, there are certain steps that happen along the way. So yes, you can actually scroll down all the way. Every single step is a different equipment that you would have designed. So as long as, so we start off with a raw material, which is media at the top there, and then we end up, so after you've produced what you want, we now need to separate things out. So basically purifying. So all of this is just purification. All of these steps are just methods of purification up until you get to the end, almost the end, where you get your final product, which is the mRNA vaccine. So this was just to simulate what the process would look like based off of material that's available. Like there are so many resources that explain how the COVID vaccine is made. It is widely available. Even I think Pfizer, you can find it on Pfizer. You can find the patent where they actually show, okay, this is what we do from A to Z. Yeah. So first of all, I had to make this flow sheet, and then I had to do the actual data analysis that was required. Yeah.
Wow.
So
interesting.
This was
very interesting.
So this is,
You really seem to love this.
I do.
Yeah, I can hear how passionate you are about chemical engineering and about research.
Yes.
And you know why I'm so excited about this? Yeah. And I'm so excited about this, Rufaro, because I have to share with you. I feel like this is an area that is not explored. Research by engineers is not really explored.
That's true.
And I've actually, this is something that I was thinking of doing, like something to just shed a light on research, but maybe we can organize for this on a later date and do that as a separate discussion so that we can be able to fully explore that career path in research, because I really feel if we don't research, then how are we going to move forward? How are we going to discover and innovate? Yeah. So if this is a pending discussion, we need to revisit.
Yes, definitely. Yes, that's really got me excited. Yes, 100%. I really enjoy research. Yeah. So
Okay.
I'm happy to chat more about it later. Yeah.
Oh, perfect. So before we finish with the flow chart, I want you to tell us, because I'm wondering what you used to do this. There's a moment you were talking about some of the tools you use in your work. So maybe you can tell us some of the tools, and maybe you can combine it with the skills that you're talking about, like the softwares and that you're going to be using on your day-to-day work as a chemical engineer.
Okay, so there are different types of software that are available for different processes. So this one that I used, it's called SuperPro Designer, and it's tailored mainly for bio processes. So your pharmaceuticals, fertilizer, biofuels, anything that's bio-related, it's called SuperPro Designer. Then another one that we used, it's called Aspen Plus. So basically that also models more to do with separation. So that purification process that I was telling you about. So yes, you're going to produce whatever product that you're looking for, but then it's going to be in a mixture, because remember, you're adding things together and then it reacts, and then you will end up with a pool of different types of compounds, but you don't want different types of compounds. You want something that's pure. So what that software does is it helps you design what's called a distillation column, where basically you can separate compounds based on maybe their volatility. So you can maybe heat it up such that the more volatile, when I say volatile, the ones that have lower boiling points will evaporate off, and then your desired product remains, which is what you then separate out and then package. So mainly those were the main software tools that we used. Otherwise, Microsoft Excel, as you can see, this flow sheet, I've added it there. When it came to performing economic analysis, you would also just use Microsoft. But now what I've noticed is data science has become very popular. Unfortunately, I didn't do that in my time. It was only introduced recently. Like after COVID, things became more remote. So now they've added data science as a module to chemical engineers, because coding is also another thing, is also something that you can use to solve mathematical models or as a tool for that. So, which is something that I really need to work on, because that's where the world is going. And just to add on to that, once you have something like Python or MATLAB as a language that you are comfortable with, that helps you branch off not only to chemical engineering, but you can also use that in data analytics in different fields. So what's interesting is that they're actually consulting companies that strictly recruit chemical engineers. Companies like, I wrote them down, McKinsey, BCG, it's called Boston Consulting Group. They actually have bursaries that are available to undergraduate students, such that when you graduate, they want you in consulting, which when I first started, I didn't realize that you could go into consulting as a chemical engineer, because the skills that you get are transferable to so many fields that aren't necessarily chemical engineering. I have a couple of colleagues who are people that I studied with in undergrad that are working in banks. Imagine a chemical engineer in a bank, because the skills that you get.
I know. Isn't it surprising?
Yeah.
So, I just want to know that you told us all the skills that chemical engineers need. So you've talked about coding and data analytics, and you've talked about 2 softwares. Please remind me what they are.
SuperPro, Designer, and Aspen Plus.
Yeah, and of course the basic tools like Microsoft, Word, and the rest. So are there any other skills that you think is essential for chemical engineers?
I think it's all engineers problem solving. Problem solving.
Yeah, problem solving. Exactly. And you talked about something. You talked of costing. You said something about costing earlier. Was it costing?
Yes.
Yeah.
So these equipments that, we still have the flow sheet there, but like something like a storage tank, the last block that says drug substance storage, something like that. They're actually, what they teach you is how to cost a vessel like that or a piece of equipment like that. It's part of, I'm forgetting which textbook, it's been a while, but it is something that also comes into your overall analysis, because you don't want to just look into, I've made my product, but then, how expensive was it? How expensive were the materials that you put in? How expensive is the material to actually build all of this? Is it stainless steel? Is it carbon steel? What is all of that? So then to make your analysis complete, you then look into all of those factors, which also then helps, because I think these are also skills that, as I was saying, you can also use in banking and in consulting. So I think chemical engineering is just great. Yeah.
Perfect. Thank you for that. So how did you go about is it something that you have in your plan? Because something else that I usually encourage, and a skill that you have to have as an engineer, you have to develop a habit of active learning. So like here you're saying, when you're studying, there was no data analytics, there was no coding. So did you have to work on it later as you're working, or you have planned out?
I'm actually going to start learning how to code in Python language, because besides R&D, consulting is something that I would want to work into. I've conducted one project that was consulting-esque, but I realized that I need to know how to code to be able to make it more efficient, to work more efficiently. I think coding is a very good, it's not like I still have the degree. It's not like it's completely, if you don't know how to code, that it's not a train smash, sorry. but I think it's a useful skill to learn, especially, can't say this enough, with the way the world is going. Yeah, coding. So I am going to learn. Thank you for calling me out on that, because yeah, it's one of my resolutions. No, like, thank you. I have to be serious about it.
Yeah.
Yeah.
And you've talked of Python, and I've heard, like, also in my field, civil engineering, it's really applicable. So it looks like Python programming is almost like useful everywhere. Yeah, I was once advised to consider upskilling on that area. I haven't done it yet, but I'm yet to look
We need
at
to
the
do
ways
it.
that
We
I can
need
be
to
able
do
to be
it.
helpful. Yeah. Yeah. Okay, perfect. Yeah. So the next thing that I would like you to share with us, Rufaro, is
Yes.
ways in which you can collaborate with other engineers and even other professionals who are not engineers, and how is it that they come in? I mean, what inputs do they have to your work, and what inputs do you have to what they're doing?
Okay, I can only speak on my experience. There was another project that was more multidisciplinary than just working with scientists. And in that's the role where I acted more as a consultant than as a researcher. And it was new. It was new because I don't know. I think engineers I think we think in the same way. I don't know, but the way that engineers think and the way that non-engineers, no, I'm not offending anyone, but like non-STEM people, actually, let me say STEM. I think it's very different. And I've had to learn. Another thing is, teamwork. Oh, yes, I did mention teamwork is something that's very necessary in engineering.
Yeah.
It comes out everywhere. But like, I worked with a team that was actually business minded. So they were looking into commercializing. So some of the research that we do at UCC in general, if it has good enough potential, it can actually be commercialized. And there are existing funders who can fund you to actually make it into a startup company. So research doesn't just end in the labs or in the research group. It can actually, if it has enough potential, it can be commercialized.
Yeah.
So I was working with that department along with microbiologists. So they're literally microbiologists. I'm a chemical engineer, and I was working with project managers there and business-minded people there. And so basically the project that we were working on, sorry, I work on a lot of projects, but it's this. So they're trying to, and I'm pretty sure you know how cannabis is taking over certain industries in Africa, or actually globally as well, especially in therapeutics. So what they were trying to do is they developed a method where, so basically when it comes to cannabis with the plant, right, there's a male version of the plant and a female version of the plant, but it's only the male, was it the female? The female version. Yeah. Plants have genders. Bio.
Yeah.
Plants have genders.
Oh, yeah, I remember. Yeah.
There's a female plant and the male plant. I'm forgetting which one. I think it's the female one that it's the male one. It's either or that produces the CBD that's actually needed in pharmaceutical therapeutics that are cannabinoid derived. So they produced a method where instead of planting, because you could only tell which one is male and which one is female at harvest, but then you would have wasted time, obviously, because imagine you've planted acres of land, but only like not less than half of it actually has the compound that you want. So they developed a method where you could actually tell the gender of the plant from maybe after a week, I think, a week or a couple of days, whilst it's still a seed. You could actually, so that's what they wanted to commercialize, because obviously that's going to help save resources that would have otherwise been used to cultivate and harvest not nonsense, but like not useful plants. So they didn't know how to cost that. They didn't know how to cost, to look into the economics of that. And it seems like the other department, they weren't keen on doing the nitty-gritties, the basics. And that's when I was called in as a consultant to see, to use the data that they had developed and to make sense out of it in terms of money, basically, to then present it back to the board of funders and project managers to see, okay, is this actually feasible if we move on? Yeah. So in that case, the skills that I used were basically the data analytics and maths. Basically, that foundation in maths, it comes through in so many areas of this. Basically. So in that case, so I had to work closely with people that think different, which is, it was interesting. Yeah. It was interesting. A bit challenging because obviously when you're working with a group of at least 6 to 10 people, and these are people who are experts in their fields and they believe what they say goes or what. It was a bit challenging. I won't lie to you. It was challenging. But then I think I developed more of like the softer skills, the communication, all of that. Yeah. Especially like when it came to, I think the one challenge that we were facing as a collective was like transparency and communication, where I would receive information from one part of the team and then the other part wouldn't know. And then when we'd come together for like a progress update, people would be confused. Like, where's this coming from? So, yeah. So there, it wasn't much of my technical skills, but more of the soft skills where I had to learn how to actually talk to people. Because if you can't talk to people, then even if you're brilliant at researching, if you can't communicate your research findings or if you can't talk to people, then it's not, you need to, So that's the only instance where I've actually worked with people from different fields, like vastly different, because, Otherwise, I really would want to work on all these things that I'm talking about in designing equipment. I want to do it because I learned how to do it, but I haven't actually physically on a plant where I can actually say, oh, this pump, I designed this pump, or this heat exchanger, or this reactor. I really would want to do that. But not yet.
Is it if you'd have an opportunity to do that? Is it still under biotech, or it will be something completely different?
I think that will be more of a design engineer, like a process design engineer. It wouldn't be. I don't think it would fall under biotech. It would be a different type of role.
All right. And by the way, just to reinforce what you said concerning communication, I think it's like everybody learns communication the hard way. It's like you're thrown into the deep end and you go there and you're so good with the technical things. And then you just realize nobody needs it. No one needs your technical, skills. You need to talk to people and you need to. And when you're talking about the working with different people who may not be thinking the way you think, and I'm thinking how that is just common across engineering,
Most of the people that I've learned with, only a few of them are actually doing something that's chemical engineering related. Most of them are in consulting and banking, which is actually quite interesting. Like, I don't know why, but that's just something that I've noticed.